Hello and welcome to our presentation. Myself Kunal Garg with my partner Monu Kumar is going to present you virtual sand casting. In this presentation we have divided our project into 8 steps and we are explaining you through each and every step.
Introduction. Virtual sand molding. This animation we have made using Blender software and SolidWorks. First of all, we made all the required models in SolidWorks and saved them in .stl format. After that, we import them in Blender and applied the required animation.
Now moving on to step 1. Placing the drag box and the mold plate. This is the very first step in the animation. In this step, we introduce a drag box over the mold plate of right dimension so that we can pour the sand in the subsequent steps. As you can see in the photos, we have 2 SolidWorks files and 1 Blender file. In Blender, we have used the same materials as are required for the drag box and the mold plate.
Moving on to step 2. The gate pattern. This is the portion of the runner where the molten metal enters the mold cavity. Gates are formed into a mold exteriors of the desired final product and must be removed by machining once casting has cooled. There are two types of gates, small gates and larger gates. Small gates are used for casting that solidifies slowly, while larger gates are used for casting that solidifies rapidly. The gates need to be placed carefully to promote directional solidification.
Now moving on to step 3. Ramming the sand. In this step, we compact the loose sand so that it does not deform in further processes due to slight movement of mold and also at the time when the molten metal is poured in the mold, because at that time a lot of pressure is created due to gases released in the sand mold. As you can see in the photo, there are lot of ramming tools. As you can see, there are 7 of them in the photo, and we have also placed a screenshot of ramming the sand around the pattern. In this process, a mold plate is used to ram the loose sand.
Moving on to step 4. Inverting the mold. The mold is inverted and upper plate is removed. After this operation, our pattern will be at the top. This operation is performed so that we can insert spur and riser. As you can see in the photos, that in the first photo, there is a plate, and after removing, we can see our pattern on the upper part.
Now moving on to step 5. Placing the cop box. This is one of the innovative way. Our required pattern is at the top. So to make riser and spur, we placed cop box. Thus the cop is placed on the drag and dowels are put on the sand to make holes for the spur and one or more risers. As you can see in the screenshot of our Blender animation.
Moving on to step 6. Placing riser and spur. A spur is the vertical passage through which liquid material is introduced into a mold, and it is a large diameter channel through which the material enters the mold. Similarly, a riser, also known as feeder, is a reservoir built into a metal casting mold to prevent cavities due to sinkage. The first one photo we have taken in the SolidWorks, and the second one is the Blender photo.
Now moving on to step 7. Removing gate pattern, riser and spur to form cavity. Now since the sand has taken the required shape and rigidity, so it's time to remove all the patterns in the mold and make the mold clear for pouring the molten metal to obtain the required shape. As you can see in the screenshot, we are removing the gate, pattern, spur and riser to form cavity.
Moving on to our last step, step 8. Final mold. This is the final mold. In this, we can pour molten metal and get the required shape after removing unnecessary gate pattern, spur and riser. For removing these things, we have a specific method so that actual shape of the required pattern can be obtained. On the pattern, we can also perform machining operations.
Hope you liked the video. Thank you for watching.